Hello students, welcome to today's session. Let us know one more concept today. Okay, that is also from electrostatics. So in general, if we consider two bodies with opposite charges, they attract each other, right? They attract each other. Similarly, if we consider two bodies having similar charges, right? They repel each other. Repel. Even for negative charges also, they repel each other. So these are the basic properties of electric charges. Now, for example, if you consider one body, positively charged body or negatively charged, I am considering positively charged body. Okay. Near to this, if you bring one more uncharged conductor, okay, conductor or uncharged body. If you bring a uncharged body, now what is the nature of force between these two? Whether they attract or whether they repel or no force. What do you think? An uncharged conductor or uncharged body is brought near to a charged body, then what is the nature of force between these two bodies? Dear students, uncharged body means that has equal number of positive and equal number of negative charges, right? Uncharged doesn't mean that there is no charge. It means that there is equal number of positive and negative charges. And also the concept of induction. So what do you mean by induction? It is a method of charging a conductor. One of the method of charging conductor, right? Induction and conduction. Two methods are there. So in induction there is no direct contact between charged body and uncharged body. So when you bring a charged body near to uncharged body, then what happens? On this uncharged body, the similar charges accumulate on farther end. Okay, similar charges accumulate on farther end, and opposite charges they accumulate on nearer end. Correct? Now it has equal number of positive and negative charges, right? So when you bring a charged body near to that uncharged body, due to induction, what happens? Similar charges accumulate on farther end and opposite charges accumulate on nearer end. Now if you consider the force between this negative and positive charges, so what is that? That will be attractive force, right? That will be attractive force. So now this is attractive. Okay, now what about this force between this positive charge and these positive charges? That will be repulsive, right? So that force is repulsive. But if you consider the distance of separation between positive and negative charge, that is somewhat lesser compared to distance of separation between positive and positive charges, right? Therefore, the force that is inversely proportional to square of the distance. Therefore, if we consider this repulsive force and attractive force together, the attractive force has more value, or the magnitude of attractive force is more compared to that of repulsive force, right? Therefore, if you compare attractive force and repulsive force, the force of attraction is greater than force of repulsion. So due to this, we can conclude that when an uncharged body is brought near to a charged body, there is a force of attraction. Okay, so that uncharged body got attracted towards this charged body. So please remember this. So if there is some force of attraction between any two bodies, that means that the uncharged, that body, that second body, for example, if you consider A and B, okay, A and B are the two bodies. If there is force of attraction, okay, if there is force of attraction between these two, then that means that if you consider this as positive body, then this second body may be negative or that may be neutral. Okay, so second body may be neutral or second body may be having opposite charge. Similarly, if you consider negative, here if you consider A as negative, this will be positive or again neutral. Okay, please know about this. So based on this, they may ask certain questions. Okay, just look at this. Here there are 5 balls. Okay, so first one, second one, 3, 4 and 5, and given that the pair 1, 2 and 2, 4 and 5, 1, these pairs attract, okay, attract each other, and the pair 2, 3 then 4, 5, these two pairs repel each other. Now the question is, what is the charge on, or what is the polarity of charge on ball 1? Okay, on ball 1, what is the polarity of charge in ball 1? Okay, what is the polarity of charge in ball 1? How you can conclude this, or how you can solve this? Just think about that. Same concept what we have discussed. So if two balls they attract each other, that means they may be having opposite charges, or that should be the second body must be neutral, right? So given that these are insulating threads, okay, okay, they are hanged using insulating threads. So actually we don't know what is the charge on first body. So let us assume this has some positive charge. Okay, let us assume that this has some positive charge. Now 1 and 2 attract, that means the second body must be negative or it may be neutral, right? Negative or neutral, I will consider that as negative body. Okay, negatively charged body. 1 and 2 attract, then 2 and 4 attract. So if 2 is positive, negative, then 4 must be positive, right? Just assumption. Okay, then 5 and 1 must attract. So I have taken 1 as positive, therefore this must be negative, right? Now what about 2 and 3? 2 and 3 must repel. 2 and 3 must repel. 2 and 3 must repel. That means this will be negatively charged. So negative, there will be force of repulsion. And next 4 and 5 must attract. 4 and 5 must they repel. 4 and 5 must repel. That means it is not possible to have negative charge here. What happens if you consider negative charge? This is taken as positive. Therefore, if you consider this as negative, they attract. But there must be force of repulsion between these two. Therefore, this must be positive. That must be positive. Okay. Now, what about this? 5 and 1 must attract. Now is it possible to attract? Is there any attractive force between positive and positive? Is it possible? No. So what you can conclude? If there is attractive force between 1 and 5, then this must be neutral, right? This must be neutral. Why? Only if there is neutral, no charge, or if it is neutral or having opposite charge, then only the force will be attractive. Therefore, we can conclude that on first one there is no charge, or net charge on that first ball is 0, right? Yes, just go through this type of problems, very important. Okay, yes.